Yes, so single sign-on in action. Let's go. Okay. Yes, let me introduce myself. Working as a software engineer for 5 years almost, and during this time was participating in multiple projects. I've been working as a team lead for a couple of development teams. And a couple years ago, one of the projects for us was an introduction of single sign-on system across production infrastructure. And we accomplished that. And from that time, I really wanted to share how we did it, what we've learned, how the custom single sign-on solution could look like, and what is the security concepts inside of it, just to make it clear for anyone who is interested. Yeah, here. Oh, okay. Good. So let's go. What's our goals for today? So today we are going to answer two major questions. What makes any single sign-on solution secure? And how to make single sign-on solution in a way that other services could join the existing working single sign-on solution in action with as less effort as possible, for sure. Okay, so let me invite you to a quick step-by-step journey of single sign-on introduction to the from the scratch to the production. So what we will be looking at. So we will start with the covering of the basis, how single sign-on solution connected to auth 2. We will designing, then we will make our system more reliable, and we'll see how to make it even more scalable. Okay, so how does it work with auth 2? So let's see what the major concepts are. And the major concepts that auth 2 is not the same as a single sign-on. auth 2 is just a framework, a protocol defining roles and their interactions one with other. And single sign-on is the architectural solution. And as you could see, they are not always exactly the same. But currently, we have the solution OpenID, for instance. OpenID Connect implements both of them at the same time. But on the couple years ago, when we are working on it, we made it by our own. So we made this solution. We implemented a single sign-on architecture using this concept of auth 2. What are auth 2 providing to us? It provides us roles, a number of predefined roles and behavior of such roles. And resource owner, client application resource, and authorization servers. Resource owner is a person, and client application is a browser in our case, typical, and resource server contains the information resource owner wants to get, and authorization server is used just to identify the person. The main flow looks pretty much simple. So user opens the client, try to get the resource from the web application, get redirected to the authorization server, and the redirect URL contains a link to the backward resource server, then provides the credentials and maybe a consent to authorization server, and redirected back with some client secret. So it's like some object that represents a user for resource server. And resource server has to use this client secret from the client application and authorize user. So the request now is processing on behalf of the resource owner. This is a theory, and we will see how this theory works in action, so in practice. We will see exactly the same schema and make it more and more complicated in advance to make the single sign-on solution more stable and secure. Let's see what will happen if there are a lot of resource services. As you can see, a lot of resource services, a lot of redirection to authorization identity server, and every single time resource owner has to populate login and password, and it is for sure it is annoying for a reason. But in theory, single sign-on server should resolve this problem. So we can just make one redirect. One time user resource owner will provide his identity, their identity to their application. And using this client secret as a tool, as a mechanism to gain access to all servers. So in theory, it is clear. In theory, it will look like this. Let's make it thoroughly and step by step. What we have in action? We have initial architecture stage when the already working production with the resources, they're connected to different authorization mechanisms and different teams working with different resources, and one of the resources has to call another resource. So this is how the reality looks like. So something is not that trivial as we'll see before. So we can start just with deploying single sign-on server to somewhere. Nobody knows currently about it because the resources are not linked to it. And we can just start with implementation the identity mechanisms for single sign-on server. Once we have it, we can then design more and more steps for it. So let's design how we add resource server to single sign-on server, how the authorization flow for the user will look like using our new single sign-on server, step by step. So every single application has a UI. Yes, in this situation, resource server has its own UI and the single sign-on server has its own UI as well. So we are once the user opens the resource UI, it redirects him to the single sign-on server with the redirect URI backward to some identity provider. On this stage, single sign-on server kind of delegates delegates this processing of the credentials of the user. So user is asked to provide the consent, and once it's gained, the user redirects it back to the single sign-on server. But in this time, oh yes, it is probably small, but in this time, the link contains concatenated, the link redirect backward link contains already single sign-on server, and as a param, the resource server is specified. And during this redirection, user already have a auth token from the some identity provider, but it could be Google or Microsoft or something like that. And single sign-on server on this stage has to understand that auth token is valid. So everything which comes from the internet, yes, should be validated. So we provide auth token to the deep of the single sign-on server, and we are making additional requests just to verify that provided token is valid. We can gain the username from it. We can validate it that everything is true, and only after that we are ready to create a client secret. So only after that we have this client secret ready to be used by user. So we are redirect the user back to the resource using the redirect URI we have before. But in this time, we have client secret populated to the client application, and client application uses client secret to access resource server. So yes, probably it looks like complicated, but we'll have a look additionally. Yes, it's totally fine. It is by design. Yes, it's not a bug. Yes, so. Yeah, let's see what is our next steps. Yes, exactly, and this sound confirm it. Security questions to be resolved. So authentication design is ready. So we know how authentication flow will work for us, but let's say what is client secret at this stage. So what is client secret from this slide? So yes, how this object is supposed to look like, and what makes client secret secured, and why resource server has to rely on it. So let's answer those questions. So basically, we have two options for our client's secret to be. It could be either a session, either a token, and we can compare properties between two approaches, but most importantly for us is to scalability, and stateless applications without any session saved in the memory of the application will help us scale across a number of resources. Horizontally, scalability is supported by a token-based authorization system as a default. So we decided to use a token-based system. And for the token-based authentication system, there is a standard protocol is called JSON Web Token, which is a method for transporting the security data between the parties. So how does it look like? It looks like the piece of the text in a browser, and if we look more thoroughly, we will see that this GWT token contains from the dot separated blocks of base 64 encoded text. So we can decode it because it's open format. And we will see that the signature algorithm is inside, username, and expired at timestamp is inside. So at this stage, we need to understand that GWT as a JOT, JSON Web Token contains expired in it. It contains username in it, and we can use it as a pieces of data we need for our resources to rely on. But wait, if we specify username as something and expiration date as never, how it will look like. So, and this is why we are using, we need to sign our JSON Web Token, and these two blocks has to be verified. What is the verification? What is the process of signing anything? This algorithm RC, so we apply RC and some encryption key, yes, private probably encryption key, to first two blocks of the JSON Web Token, and we are currently here, and at the bottom we are applying this exactly to first two blocks of their object. And what we've got a signature of this exactly GWT, and this signature is unique for two first block. The only one possible signature is available. So final GWT looks like first two blocks contains user data, algorithm and user data, and the second one, the last one, is like a signature, the signature of this GWT. So how it is validating? So if a resource server is asked to check whether this GWT token is valid or not, we are applying decrypting to this signature. So we are decrypt what we've encrypted on the previous step, and when we decrypt it using encryption key, we are supposed to have exactly the same blocks. If we've got exactly the same blocks, it is for us it means that GWT token is truly signed. So it means that on the moment of the creation, creator knows the correct encryption key, which means that the GWT is valid. Imagine the situation when we specify our custom fake data, user admin, expiration never, and we don't know the exactly encryption key. So we will use some fake key for this situation. And during decrypting with the correct key, we will got different topics. We've got different blocks, and GWT will have no signature in this situation. So basically, this is our this is on what we are relying on. We are relying on encryption key. We are relying on GWT, and we will need to use encryption key to create GWT and to validate it. So, what we are currently looking at. So in our system, we have encryption key, yes, to create those tokens. And if somebody will have an access to this particular encryption key, it means for us that this person is able to create any amount of the GWT tokens, and they will have no difference with the tokens issued by single sign-on server. That's the problem of symmetric encryption, which needed only one encryption key for encrypting. This is why we are having asymmetric encryption. So in case of asymmetric encryption, we are using public and private keys. Public public key is used for decrypting the message, and the private key is used to encrypt it. So if something is compromised, the whole system is not supposed to be compromised at all. So we are having these two keys in the single sign-on server or in deployment structure. It doesn't matter to us. And we can easily share our public key because it is supposed to be shared. And the only thing that resource needed to know is like how to validate it. And it is mostly it is discussed as in case of compromising the one resource server, the whole system could not be affected by the public key knowledge because it is basically nothing for anyone. The only positive thing here is like the person is able to understand that this particular GWT token is valid. It's a good point. Okay, so how does it look like for us if we are working with this token? So if our client application has GWT token in application memory, I mean in a browser, so with every call with to the resource server will use GWT token. So it is mostly it's clear and transparent. And every call resource server will validate it using using public key. Okay, but GWT token has expiration time, so before it expired, we need to refresh it. So we need to apply. We need to ask single sign-on server to refresh our access token. Also has to be validated by public key, and new token will be created using a private key. So it is mostly simple. And there is a holy war between between two groups of people. So somebody tells that single token is enough and single token is able to do anything, but auth 2 encourage us to use two tokens, one for many use accesses and one for single use access. One is really short and one is long. So both tokens has to be used just to separate the duties between those tokens. So how it will look like in action, how it will look in our single sign-on processing. So we will have GWT for access, and we will have GWT for refresh, and both of them will be storing in our client application. So we will use GWT access to access resource server, and once the expiration time is really near or close to near to be expired, we will use the one-time token to refresh those tokens. So once it is sent to single sign-on server, we will get two tokens back and we replace them. So just to make sure, so we will use really long one for longer than 30 minutes refresh token. It will not be used by a resource server, but it will be really convenient for client application to refresh both of them during the single sign-on processing. So how our final flow will look like in case of two tokens and public keys. So basically, user redirected one time. The right side of this from this redirect flows are not touched. So the same thing, we are got back with auth token. Auth token has to be validated. We are validating it. Okay, the token is ready to be prepared. So we are creates a pair, access token, refresh token. We are using private key for creating them. Single sign-on server is authorized to do so. So, and once we are redirected back, we are receiving on the resource side, we are receiving two tokens, access tokens and refresh tokens, just as a query params. And we are ready to use access token to access our resource server. So that's complicated thing is happening in the browser really fast for the user, but step by step, it is how it is working in most single sign-on solutions with external identity provider. So this is our final flow, and we can move on. And let's speak just a little about reliability. So when application breaks, everything breaks. What happens? So I don't know, maybe you notice it, but in the middle of December 2020, for 15 minutes, Google Cloud Platform was not able to provide authentication, and it was global outage. So even internal, as you can see from the accident report, even internal users were affected by this Google account authentication. And what does it mean for us? That in our case, we need to make sure that we do not depend during the single sign-on processing. We do not depend significantly on external identity server. So we can extend refresh token as much as I don't know, as securities team suggests us. So in our case, it was 30 minutes. It's enough time span for the user. So if you are not on the keyboard for 30 minutes, so it means okay. But if it is more than 30 minutes, so you will be asked to prompt your username or give a consent to Google or to Microsoft, I don't know, authentication. So it's okay. Also, you can use two-factor authentication or multi-factor authentication or IP check during the creation or refreshing of tokens. We can use additional mechanism just to make sure that the user is going to make a valid change. So we can store this information, and I don't know, for instance, we can store for this user API to be used during the last refreshing. So if it is significantly different, so let's just be in case, let's move on to the, I don't know, external identity provider. Okay, what is about scalability? So we're thinking that for our scalability, we are using Spring Boot applications across the infrastructure we were working on. And for us, it was really convenient to use a Spring Boot Starter, thing to provide all the necessary configurations. So we put in the starter HTTP filter with all requests. We put web configuration, domain object, and some configs to Spring Boot Starter. So any resource has to just include this starter to start working with our single sign-on architecture. But the main thing here, they need to remove all the existing web configuration for sure, because it will be replaced by our custom one. Also, HTTP filter is working the same way for anyone. So with for any resource, it's working at the same with the same methodology. It checks GWT token on access. So it's basically it. And what is needed in action for us as developers to implement to add this single sign-on starter to the resource. So we need to implement user single sign. We need to implement our custom custom retrieval of the user by username, because this verification is working that we got the string, but we don't know the exactly role. So we rely on the resource. That resource knows what are the roles for particular username. And if in application YAML, we need to put something like address to our single sign-on server and public key for encryption, because every resource has to validate GWT tokens. In POM, we just include the dependency on this starter, and that's it. Basically, it was used a couple times, and it was working fine for us. So the solution was confirmed valid. So new resource was included in the whole system with really not that a lot of effort, you know. So yes, just to sum it up, if we've covered just basic concepts of auth 2, single sign-on, GWT validation, asymmetric encryption, access, and refresh tokens. So asymmetric encryption used to create and validate GWT tokens, access tokens, and refresh tokens are used in pair to split the duties between those two operations, and to reduce the single sign-on integration issues, the really problematic thing. We can use, if we use it for sure, Spring Boot stateless applications, we can use custom starter, and it will provide less effort for us. So all of the discussed mechanisms and technologies are widely used across different auth systems. They are very universal, and I hope that it was a comprehensive overview of single sign-on architecture, and we saw how does it work, I don't know, in action. Yes, so how does it work in real time? So yes, okay. Okay, if anyone has any questions at this moment, so I would like to address it. Maybe something is not really clear, or something is needed to be elaborated. So yes, it's a time. No questions. Okay, thank you so much, but it's not that. So we have some extra time, I suppose. It is great. So if we have some extra time, let's spend it on the next problem. So imagine we have access and refresh token, and GWT token itself doesn't have any kind of attribute that so that stating I was already used. So please do not use me one more time. If it is used, it's used, but there is no tool to measure it. So in every single time we made it from the scratch, we implemented kind of caching mechanism for accumulating all the already used refresh tokens. So we just know that this refresh token was used. The problem here that with if you have a lot of systems, a lot of resources, and a lot of I don't know, a lot of users refreshing their tokens, you could be out of the memory in this situation. So we just make a simple concurrent cache with a life duration equals the time span of our refresh token, and it helps us to just have really a naive way of processing it. So it was the solution, and so you've got this extra for free. Yeah. Thank you so much. I think some of you got something new and interesting, and the whole thing of single sign-on processing becomes more transparent for at least someone from you. Thank you so much, guys. Yeah.